I just wrote that if we're trying to prove that this is equal to sine 2 beta, that is 2 sine beta cos beta. So then I thought, okay, I need to obviously change tan to sine over cos. But then I need to try and get a sine at the top, right? Because I want to get a sine 2 sine beta cos beta. So I decided to use the sine one. I don't know, did anyone use either of the other two? It would have worked out, it maybe would have just been a bit longer. So then if you do 1 minus 1, that's 0, right? So you're actually just left with positive 2 sine squared beta. But then, guys, this is a compound fraction, right? I have a fraction within a fraction, so I decided to just multiply the top and the bottom by the denominator, which is cos. Which then actually worked quite well, because then I could just cancel out one of the signs of the top with the sign of the bottom, and I got exactly what I wanted, what I needed. I suppose I should have just added in an extra step saying that this is equal to sine 2 beta. There we go. And then it goes on the case. Does anyone have questions on that one? Okay, E was quite a nice one. That was the difference of two squares. We just had to factorize. Cos squared plus sine squared is 1, and cos squared minus sine squared is cos 2 theta, which is exactly what we needed on the right. It probably would have been fine if you went just from this and said equals RHS. I mean, everyone knows that 1 times cos is just cos. So that would have been fine. I'll just move down so that you can see H as well. On the side here, I'm just going to show you, if we need to get cos theta minus sine theta squared, I just actually worked out what that was. So that I know that once I got into this point, I do have the right-hand side. So I actually am looking for these 3 separate terms, because when you factorize this, that is what you get, right? So I just spoiled this out. So I'm actually trying to get to those 3 terms. So the cos 2 theta, in this case, I changed to cos squared minus sine squared. 2 sine squared theta stays the same, and sine 2 theta became 2 sine theta cos theta. Then I just collected like terms, and then it actually worked out from there. So it was cos squared theta, that was the only one. The middle term is this one over there. And then negative sine squared plus 2 sine squared is just 1 sine squared, so that's that term. And this is exactly what you get when you FOIL this out. The right hand side. Yes. We'll answer same on both sides. So like for I left my answer as cos squared on the right hand side, and then with my left hand side is equal. So are you saying that you wrote RHS equals cos squared theta and LHS equals? Yeah, that's fine. Okay. You'll see now in J, I actually did that. I actually did the left hand side and the right hand side. So yeah, that's fine. Okay, guys, yeah, for J, I don't know, maybe some of you found a simpler way, but I worked on the left, and then I got to this, and then I thought, okay, now I can times the top and the bottom by the conjugate, but let's see, maybe it will be faster if I work on the right-hand side. It probably wasn't faster to do it like this, but yeah, like I just said to Talia, now you can work on the left-hand side, get it to something, and you work on the right-hand side, get it to that same thing. Or you could obviously just do it left hand side until you get to the right hand side. Did anyone get to this and then multiply by the conjugate at the top and the bottom, and it worked? Okay. Yeah. Okay, so that also would have been fine. So guys, if you got to this step, just first let me make sure everyone's fine here. Tan is sine over cos, and tan is also sine over cos. Right, that's where that first line comes from. Then that's obviously a compound fraction. So you need to multiply the top and the bottom by the LCD of the inner fractions, which is cos. All right, so you're going to do, and now remember, because it's 2 terms here, you need to multiply both of those terms by cos, right? So you're going to say 1 times cos is cos, and then minus this whole thing times cos. The cos is going to cancel out, so you'll be left with minus sign. At the bottom, the same thing. 1 times cos again is cos A, and then plus, and then sine of the cos times cos is just sine. So then from here, you could have multiplied the top and the bottom by cos A minus sine A. I don't really know why I felt like I didn't always be on doing that. I was just like, let's work on the right. But yeah, then that also would have worked. Then you would have had to boil everything off and then go something. So that is what I did. I then looked at the right and I changed it to cos squared minus sine squared so that I could factorize it. Then I did that whole thing that we wrote in our notes. I changed this 1 to cos squared plus sine squared. I then factorized the top and the bottom, and then I could cancel off. Good job, guys. For these identities, often there are loads of different solutions on the memos because, yeah, you could do many different things. And if you are coming up with a solution that's not on the memo, we'll add it to the memo. And we basically look to see if we did something that was mathematically sound and it worked. Yeah. Good morning. Okay. Very well. Okay, guys, we're done with identities for now. We are going to practice some other types of questions today. You guys keep put away on the phone. Whatever this book is, thank you. It's right in front of you. Okay, try to work that out on your own, please. See if you can figure that out. Yeah. Yep. Thank you. Yes, without a calculator, guys. No. Yes, we have done that before, but yeah, it's not like you won't be able to do that in an exam. You still get a mark for your triangles. Guys, what do you do when you have a bracket squared? You write two brackets and you FOIL them out. Do that, please. So let me help you guys out with that first step. Because what you, okay, I see what happened now. Because we have in the past calculated cos 15 and sin 15, maybe you thought you had to do that whole compound angle thing, right? It's fine, it would have worked, but it would be a hell of a lot of work, right? Because then you're going to get cos 15, when you expand that is going to be 2 terms. Sin 15, when you expand that is going to be another 2 terms. Then you must square all of that. All right, so yes, it would work. It would just be a lot of work. So I would suggest rather square these brackets out before you start, or FOIL them out before you start actually trying to find the values of those of cos 15 and sin 15. If in a test or exam, maybe you had calculated those two values before, right? Say it was 1.1 find cos 15, 1.2 find sin 15. Now 1.3 find this. Then absolutely you can use those values and put them in and square that. What did I do now, man? I meant to write two brackets next to each other. So cos 15 minus sin 15. Sorry, that is what I meant to do actually there. Now I'm going to FOIL them out. Cos times cos is cos squared 15. If I do my outers, I'm going to get negative sin 15 cos 15. If I do my inners, I'm going to get the same thing. Minus sin 15 cos 15. And then when I do my last, a negative times a negative is a positive, and sine squared, oh, sorry, sine times sine is sine squared. So that's going to be sine squared 15. And that makes our lives a little bit easier because what do we have here? Cos squared 15 plus sine squared 15. What's that? 1. Cos squared plus sine squared of anything, as long as they're the same angles, right? Cos squared 15 plus sine squared 15 is 1. So I'm actually just going to put in an extra step where I'm going to write those two next to each other. You wouldn't have to. You could just put in a 1 straight away. but I'm just going to write that down so that you can see easily when you look back at this. That is equal to 1, right? It can be any angle as long as they're the same angle. Then cos squared and sine squared when you add them is equal to 1. What do I have here, guys? Minus sine 15 cos 15 minus the same type of term, right? These are like terms. So what's that? Minus 2 sine 15 cos 15. And does that look familiar? Okay, I'm going to write on the side here. Sine of 2x is equal to 2 sine x cos x. You guys see that I have a 2 sine x cos x situation here. 2 sine 15 cos 15. Right? So I now actually have the expansion of the identity here, of this double angle identity. So guys, that's why I said it's good if you actually know these identities so that you can recognize them. Right? If you don't actually know them, then you might not realize that, oh, this is the expansion of the sine double angle identity. So how does that work, guys? If it's 2 sine x cos x, that's equal to sine 2 times x. So what is my x in this case? 15. So this is going to be equal to sine 2 times 15. Right? Again, this is 1. Right? 1, maybe I should just underline that. Cos squared 15 plus sine squared 15 is 1. Okay, minus. Okay. All right, I'm just going to say that again. We're looking at this part. This is what we actually have now. 2 sine x cos x. 2 sine 15 cos 15. That then becomes sine of 2 times x. So whatever these angles are here. Right? So this is going to become sine 2 times x 2 times 15. And minus sine. And what is 2 times 15? 15. 1 minus sine 15. Yeah, that is a half. Hey, just remember, guys, let's do this properly. You have to do your triangle. Here we go, that's the answer there. This is a familiar guys when they're telling you that sine is equal to a fraction and they're telling you that the angle must be between 0 and 270. And then they've given you cos of another angle. They've given you some more information about that angle as well. So guys, this is basically something that you learned in, actually in grade 10, you did these types of questions for the first time. Then we did them again in grade 11, but now we're adding a grade 12 idea. Okay, so are we seeing how the grade 11 stuff is linking up with the grade 12 stuff? Same types of questions, but you need to be able to apply the new identities. Now guys, for this, it's saying without using a calculator, right? So we can't calculate angles P and Q by doing a shift cos and a shift sine thing. All right, then you're going to get 0 straight away because you used your calculator. Can anyone remember what we need to do in this case? We need to draw a triangle on the Cartesian plane. All right, we're going to have to draw one for P and one for Q. Okay, cool. And here's how we come through. That's a little great. They're saying here sine is negative. In which one is the sine negative? Sine is 3 and 4. Hey, do we remember our class diagram, guys? Just draw it there on the side. We haven't actually used it yet this year. Class diagram. So sine is negative in quadrants quadrants 3 and 4. So now how do we decide? They have to give us another piece of information. Right, because we can't draw a triangle in both quadrants. They're telling us that P has to be between 0 and 270. So can it be in the fourth quadrant, guys? No. All right, so 0 and 270, that includes quadrants 1, 2, and 3. I mean, it does, yeah, but it's not that. So P is an acute angle, so it's not actually going to lie on that line. We're just saying it can be quadrant 1, 2, 3. And guys, which quadrant is coming up in both of these? 3, right? So that is how we decide that our P triangle is going to be in quadrant 3. Okay, so you're going to draw your quadrant 3. We're just going to draw a triangle of any size in this quadrant. It doesn't actually matter. Remember, we're not trying to do this to scale or anything. It has to be a right angle triangle, obviously. And then we just show that that whole angle is angle P. We're looking more familiar now, guys. Okay. Now we're going to have to use the fraction that they've given us, right? We know that sine is opposite over hypotenuse. So they're giving us the length of those two sides in that fraction. But we need to also remember that now either the 3 or the 5 has to be negative because this is a negative fraction. Now guys, can one hypotenuse ever be negative? No. All right, so the other side is going to have to be negative. The opposite side, all right? So this is my angle. This is going to be the opposite side. So this has to be negative 3. And does that make sense? That is on the negative part of the y-axis. Okay, so it has to be negative 3 here. Our x value is also going to be negative 3, or our x length. Right, is that clear to you because of the quadrant that it's in? This is on the negative side of the y-axis, so it has to be negative 3. That opposite side, I'm getting it from there, and the hypotenuse is 5. What do I have to do next? Pythagoras, right? To find that third side. Now, guys, some of you might know what it's going to be already, just kind of like from memory. If it's 5 and 3, what's the other one going to be? 4. All right, but it's going to be negative 4. That's very important. I will show you the working for that now as well, in case you don't know those values by heart. That's negative 4 there. The negative is very important, guys. On the negative side of the x-axis, so it has to be negative 4. You could do your calculation here. You could say that x squared is equal to, I'm calling it x because it's the x length, right? Is that fine with everyone? X squared is equal to, remember hypotenuse always minus the other side. So I told you guys last year, you can just write 3 squared if you want to, because that is actual length, or you can write negative 3 squared, it's fine, it's going to give you the same answer. Right? Because what is negative 3 squared anyway? It's just 9. Okay, you're going to get the same answer from that. So this is 25 minus 9, which is 16, right? What else? No, it's fine. Yeah, that's what I'm saying. You can put a positive 3 or negative 3. It doesn't matter. Okay, so then if x squared is 16, then x is going to be plus or minus 4. Remember, we have an x squared equal to 16. When we take the square root over, we're supposed to say plus or minus the square root of 16. But which one am I going to choose? Guys, this positive x or negative x? Negative. All right, so we used to say that quadrant 3, therefore x equals negative 4. Now guys, if you know that value off by heart, or if you want to just do the calculation quickly on the calculator, are you listening? Are you listening? If you know that's 4 already, if you know that that's going to be a 4, or if you just want to do it on the calculator quickly, all you're going to get a mark for is just saying x equals negative 4 and writing Pythagoras function. So you don't actually have to show all of this working and show that it could be positive or negative. You actually just need to show that your value is going to be negative 4 and that it is because of Pythagoras. Okay, that is what you get a mark for. So if you know what that is already, don't write down all that working. You can just write the actual value. But you have to say that it's Pythagoras, right? You're going to lose a mark if there's no Pythagoras. Okay, so we've done our P triangle. We still need to do one for Q. Okay, so let's take a look. Now they're saying that cos of Q is positive 4 over 5. All right, so which quadrant or in which quadrant is cos positive? 1 and 4. And now they're saying Q has to lie between 180 and 360. Which quadrants are those? Is that? Oh, those. 3 and 4, hey? Because it's 180 is that line to 360. So it's those two quadrants. Quadrants 3 and 4. Which quadrant is in common between these two? 4. So our Q triangle is going to be in quadrant 4. Now guys, you could draw it on the same set of axes, but then it gets a bit busy, alright? I would suggest just drawing a separate one for each. But if you want, you can do it on the same one. Again, you're just going to draw your right angle triangle. You're going to go from 0 all the way to that line. That is now angle Q. There isn't really a reason for this triangle being shorter than the other one. I'm just it happened like that. So guys, when you're looking at the fraction that they gave us, we're saying that cos is 4 over 5. Now we need to remember that cos is adjacent to the hypotenuse. So if this is our angle, the adjacent side is 4, right? And that obviously has to be positive 4 because it is on the positive side of the x-axis. And then the hypotenuse is going to be 5. What is that other side going to be, guys? These two triangles are actually the same, right? I'm noticing that they're just in different quadrants. So what is that side going to be? Is it going to be 3 or is it going to be negative 3? Negative 3, right? It's on the negative side of the y-axis. So here you would just have to write y equals negative 3. I suppose it's fine if you just put it on the picture, right? So you can see that there's a negative 3 there. And you don't have to write Pythagoras again if you've already written it. Okay, let's write it out in full just for this one. Just so that when you look back at this, you know where that negative 3 came from. But actually, you would have gotten full marks if you just filled it in on the picture. Okay, so now we can finally actually start answering this question. The question is asking us to determine cos of q minus p without using a calculator. Now guys, I've said this before, but I'm going to say it again. If it says without the use of a calculator, can I find the values of angles q and p? Can I find those actual sizes? No. So I can't just put in an angle here and then another angle and then work it out. Okay? I'm going to have to use my triangle. But what if I do before I can use my triangle? To expand this, hey? Using my compound angle identity. So cos of q minus p is going to be cos q times cos p. Remember for the cos one, we use a different sign from in the bracket, so it's going to be a plus in between them, and then sine q times sine p. Now you can use your two triangles to actually find the values of cos q and cos p and sine q and sine p. Right, those fractions. Do that on your own, please. After using a calculator, use your triangles now. Cos q, I'll just do the first one with you. Cos q was actually one that they gave you. Alright, but just you would look at this angle, you would say cos is adjacent over hypotenuse. So the first one is going to be 4 over 5. Okay, then we do that with the other three as well, and then multiply them and work that value out. Please find the answer. Okay, there we go. That's what I got. Please. Okay, so you just use your triangles to get those four angles, or those four values rather. Those four fractions, then you multiply, and then they have the same denominator, so you can just add them together straight away. And that's the simplest form. Guys, if that wasn't the simplest form of that last fraction, you would have to simplify that. Okay, so if you got like a 5 over 25, you would have to simplify that. Okay, 7 over 25, that's simplest form. Okay, so guys, you do have to remember the types of questions that we did in grade 11 and be able to apply the new, what's it called, identities to those. So I'm just going to give you a few to practice for homework. And then tomorrow we are going to start looking at trig equations again, which is quite a big thing. Okay, number 5 and number 8. Number 5 is just simplify, get to like a number without a calculator. Then for number 8, they're telling you that sine 21 is equal to A. Right? We just talked about this last year, but we haven't practiced one exactly like this now. So what you need to do is you need to write that as A over 1. Alright, and then that means that if you are drawing your 21-degree triangle, the opposite side is A and the hypotenuse is 1. Alright, so we remember that we did equations like this last year. Okay, so they're telling you now, not sine X or sine P or whatever like we did now, they're giving you an actual value for that angle. Then sine 21 is A. So you need to write that as A over 1 and use that to set up the triangle. Now you're going to use Pythagoras to find your third side. But now obviously because there's an A, your third side isn't going to have a value, alright? It's going to be something in terms of A that you need to calculate. So you're going to use Pythag to do that. Then they're asking you, I'm just going to help you with the first one. For 8A, they are then asking you to, without using a calculator, express in terms of A. The first one is sine of 339. So that's in your triangle, you have a 21-degree angle, and that angle, what's that going to be? The third angle in that triangle. 9 to minus 21, hey? 69, there you go. All right, so those are the two angles that you're going to use. So guys, you now need to try and rewrite 359 using either 21 or 69. All right, can you think of an idea? 360 minus 21, isn't it? 360 minus 21 degrees. That's the same as 339. And what quadrant is this, right? 360 minus is quadrant. Or what is sine in the fourth quadrant? Negative. So this is negative sine 21. So guys, if sine 21 is A, what's negative sine 21? Negative A. Right, that's how you need to answer those questions. So that one goes to E. I've done A for you as a quick example. So please take a picture of that so that you have that example. For the others, guys, you might have to use column ratios. Okay, if they're asking you something with a 69-degree angle, if you have your triangle, you can just use the triangle to actually find that fraction. Okay, but basically for these types of questions, you're going to have to use reduction formula and a triangle to find those. Okay, I'll write down the 5 down for you so that you can do that one now. It's just saying determine, and then you must calculate this one. Okay, so without a calculator, you're going to try and work out what that is going to be equal to. And then I've done 8A for you, so you can copy that one down and then look at